Simplifying fractions. When you solve a problem involving fractions, you will sometimes be expected to simplify your final answer. This can involve taking one or more of these steps. Move any negative signs out of the denominator. Cancel factors that are in both the numerator and denominator. And convert improper fractions to mixed numbers. These steps are not usually taken while solving a problem, but can be taken when presenting the final answer. Mathematically, if there's just one negative sign in a fraction, it doesn't matter where it appears. It could be in front of the fraction, like here. It could be in the numerator, and technically it could be in the denominator. These are all equivalent. However, we don't really do this. It's not standard to put the negative sign down here. If anything, move it out front. You could leave it in the top. These are more acceptable ways to have that negative sign. If you have two negative signs in a fraction, they cancel out. Similarly, multiplying two negative numbers results in a positive number. Dividing two negative numbers results in a positive number. Final answers, like the two on the left, should be converted to the form on the right. So if you have -1 over -3, those negative signs cancel out, you just get 1/3. Or if you had -1 over 3, those two negative signs will cancel out. You still end up with 1/3. Next, you're going to cancel factors that are in both the numerator and the denominator. If there are common factors in both the numerator and denominator, the answer would not be considered reduced to simplest form. By canceling out those factors, you create an equivalent fraction that has the same value but appears simpler. Mistakes are often made when canceling out common factors, so it should be done carefully. The next slide shows how cancellation works. It should be understood before you start just crossing out numbers. Here are the formal steps to simplify this fraction, 4 over 6. So first you're going to break down each of these numbers into their prime factors. So 4 can be rewritten as 2 times 2, right? Remember these trees? 2 times 2. And 6 can be written as 2 times 3. So therefore we have 2 times 2 in the numerator, 2 times 3 in the denominator. You're going to remove an equivalent fraction of 1. Since we have a 2 over 2 right here, we're just going to separate it. We're going to make that into a 1, and then we can just get rid of it. The factor of 1 is not needed, leaving behind the original fraction in reduced form. 2/3 is equivalent to, but simpler than 4 over 6. A less formal approach would be to rewrite the numbers as their factors. So 2 times 2 in the numerator, 2 times 3 in the denominator, and then cancel out common factors that are in both the numerator and denominator. So you have 2 here, a 2 here, just cancel those out. Now you have to cancel 1 with one other one, numerator and denominator. This 2 does not get canceled out. So just 1, 2 up in the top, 1, 2 in the bottom, those are gone. You are left with 2/3. So the step of removing that fraction equivalent to 1 is implicit. You don't have to do it. You can just cancel out these 2 2's. An even faster approach is just to recognize the common factors that exist within the numerator and denominator and just cancel them out, writing in the new numbers. This works if you are careful, but is prone to error, especially if there are many factors. The justification is the same, but the steps are hidden. Note 1, if you cancel out a common factor in the numerator and denominator, it is replaced by a non-zero integer. Note 2, only numbers that are multiplied, factors, can be canceled, not numbers that are added or subtracted. Finally, if required for your final answer, you might have to convert an improper fraction into a mixed number by the reverse process we use to convert a mixed number into an improper fraction. Just divide the denominator into the numerator and state the answer with the remainder over the original denominator. So 8 over 3 becomes 2 and 2/3. So 8 divided by 3, well, 3 goes into 8 2 times. 2 times 3 is 6, so there's a remainder of 2, and you put that over the original denominator, 3, 2 and 2/3. None of these simplification steps change your answer. They just put it in a form that may be required. These steps should not be done at the beginning or in the middle of solving a problem. Use them only when you are writing your final answer. Simplify these fractions. All right, I'm going to start with the first one here. 6 and 9. Well, if I rewrite these as their prime factors, we would get 2 times 3 and then 3 times 3. And look at that, we have a 3 and a 3, leaving behind 2/3 as our answer. Okay, so 21 and 63. I'm going to rewrite these as the prime factors. So 21 is 3 times 7. Now, 63 is going to be divisible by 3 because 6 plus 3 is 9, which is divisible by 3. And in fact, 3 times 20 is 60, which means the answer must be 21, right? So 3 times 21. Now that's not broken down all the way. We could take another step down here because once again, 21 is 3 times 7, right? So we have 3 times 21, which is 3 times 7. Now let's go cancel some stuff out. We have a 3 here, cancel out a 3 there. 7 and a 7, and we are left with nothing over 3. However, if there's nothing left on top, that just becomes a 1. So the answer is 1/3. All right, for this one, I'm going to take a little bit of a shortcut because I know that both of these numbers are divisible by 5. So what I'm going to do is just divide the top and the bottom by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. And that's it. We are done. If you had gone through all of the steps, you would get the same answer at the end. Finally, we have 28 divided by 70. This one's not as obvious, so let's go ahead and make our little prime factor trees. 2, 3, 5, 7. We shouldn't need more than that. So 28 is divisible by 2, and it's 14. 14 is also divisible by 2 times 7. So there we go. Those are the factors in the numerator. 7. In the denominator, we have 70. So I'm going to write it over here. I'll write right here. 70 is divisible by 2 times 35 is 70. 35 is not divisible by 2. 3 plus 5 is 8, so it's not going to be divisible by 3. It is divisible by 5. So 5 times 7. Therefore, we are done. 2, 5, and 7. All right, now let's cancel some stuff. We have a 2 and a 2. We have a 7 and a 7. What's left? 2 over 5. And there you have it. Remember, if you cancel out the same number in top and bottom, you can just go ahead and replace it with a 1. So 1, they all just become 1s when they get canceled out. Simplify these fractions. 27 over 9, well, 9 goes into 27 3 times. The answer is 3. You could also write it like this, 9 into 27, 3. So this is an improper fraction, but it's not going to become a mixed number. It's just 3, just a whole number. You could have also broken it down into prime factors, 3 times 3 times 3, divided by 3 times 3. You see that those 2 3's cancel with those 2 3's, leaving behind a 3. All right, next, 28 over -6. Now that negative sign can just go right out front. We're not going to forget about it. The answer will be negative. But for now, let's just find the prime factors of both of these numbers. So the prime factors are 2, 3, 5, 7. 28 is divisible by 2. It's 2 times 14. 14 is divisible by 2, 2 times 7. So we have 2 times 2 times 7 divided by 6, which is 2 times 3. Don't forget that negative sign. Now canceling. We can only cancel this 2 and that 2. Those become 1s, right? So we are left with 2 times 7, which is 14, over 3. Bring that negative sign down. The answer is negative 14 over 3. Should we turn this into a mixed number so that we don't have an improper fraction? Sure. So we can do the division. 3 goes into 14. Well, 3 goes into 12. So it goes 12 times, or 4 times. 3 times 4 is 12. Therefore, we have a remainder of 2. Put that over the 3. 4 and 2/3. So, and once again, it is still negative. So negative 4 and 2/3. Both of these are correct. All right, so you can see negative 4 and 2/3. Awesome. Okay, 15 over 11. Well, 11 is a prime number. So we're not going to be able to simplify this at all, but we can convert it into a mixed number. So 11 goes into 15 one time with a remainder of 4. So the answer is going to be 1 and 4/11. Now let's just reverse this just to make sure we get this right. Well, actually, first I'll do the long division. So 11 goes into 15 one time with a remainder of 4, and we put it over the 11. There you go. Now just to check, look, if you take 11, multiply it by 1, add 4, that becomes 15 over 11. So the answer is 1 and 4/11. Here we have 28 over 8. Now I know both of these numbers are divisible by 4. So if you divide the top and the bottom by 4, remember we can multiply both the top and the bottom by the same number, right? As long as it's equal to 1. You can also divide both the top and bottom by the same number. So 28 divided by 4 is 7. 8 divided by 4 is 2. 7 over 2 is the answer. However, if we want to convert this into a mixed number, we're just going to do that division. 2 goes into 7 3 times. 2 times 3 is 6. We have a remainder of 1, and we put it over that 2. The answer is 3.5. And there you have it, 3.5. When multiplying larger numbers, it can save time and avoid mistakes to simplify while you multiply. This becomes very important in algebra when working with variables and expressions. Set up the multiplication the same way, but then factor each numerator and denominator before multiplying. Cancel out common factors from either numerator and either denominator. Keep careful track to make sure you only cancel out pairs of factors that appear above and below the line. Then multiply. This process allows you to work with large multiplication problems without a calculator. You may need to have paper to factor the numbers. That is not shown below. So here we have 10 over 21 times 14 over 20. So we set up the multiplication the same way we normally would, but now we're going to factor everything. So we're going to cancel out the common factors that exist anywhere in the numerator and anywhere in the denominator. So for example, there's a 5 here and a 5 over there. So we can go ahead and cancel those. So 5 goes away. We have a 2 here and a 2 there, so we can cancel those. We have another pair of 2's here and here. So that leaves us with a 1 up here, right? Those go away, so leaving a 1 with a 3 below. Over here we have 1 over 1. So therefore it's 1/3 times 1, which is 1/3. Okay, so we have a multiplication problem. We're going to use our prime factors, and so on. So 250 is divisible by 2. So it's 2 times 125. But 125 is 5 times 5 times 5. So we have 5 times 5 times 5. 81 is 9 squared, and 9 is 3 times 3. So this is 3 times 3. That's 9 squared. So we need 3 times 3. Now we do the other side. 27 is 3 times 3 times 3. And 100 is 20 times 5, but 20 is 4 times 5. I'll just do this over here. 20 is divisible by 2, so 2 and 10, 2 and 5. So I'm going to go ahead and say, all right, we have 20 times 5, but 20 is 2 times 2 times 5. 2 times 2 times 5. So you can see we have 5 times 5, which is 25, times 4 is 100. All right, now we go in. So we have a 2 up here and a 2 down there. Boom, gone. 5 and a 5, another 5 and a 5. We have 3 3s. Here we have 4 3s. So 3 of those, 3 of those. What's left? We have a 5, nothing over here. 3, and a 2. So therefore, 5 6 is the answer. All right, let's do it one more time, step by step. First, we're going to factor both fractions. So all of these numbers, we break them down into their prime factors. Then we're going to cancel pairs of factors that appear in either numerator and denominator. So a 5 over here can cancel a 5 down here. All right, so you can see we've canceled out a bunch of things, right? This 5 canceled with that 5 canceled with that one, and so on. Finally, we're going to write the product down here with the remaining factors. We're going to multiply them together. In the numerator, we only have that 5 left. In the denominator, we have the 3 and the 2. So we go ahead and multiply those together to get our answer, 5 6.